let's solve a beast of a question when it comes to reciprocated trig functions and Pythagorean identities. So solve between 0 and 2 pi cosec to the power 4 minus cot to the power 4 is a half plus root 2 cosec x. Now, obviously we need to convert everything into one trig function. I see cosec and cot. Now, what is the relationship between cosec and cot? That is 1 plus cot squared is cosec squared. Well, unfortunately, this is power 4, so it doesn't apply. So there's no such thing as 1 plus cot to the power 4 is cosec to the power 4, okay? So what we need to do is manipulate this to somehow get squares only. Power 4 squares, I'm thinking about factorizing. We're subtracting two square numbers. Because remember, what is this saying? It's saying cosec squared x all squared minus cot squared x all squared. It's in the same form as x squared minus y squared, which becomes x plus y, x minus y. It's just your x is cosec squared and your y is cot squared. And that's what happens here. So when we factorize that, we're going to get cosec squared x plus cot squared x. So you're adding them, and then we're going to multiply it by subtracting them. Cosec squared x minus cot squared y, not y, x. All right? So factorizing this, you get cosec squared plus cot squared times cosec squared minus cot squared. Okay? Now, what do we know about one of the brackets? Luckily for you guys, I wrote this at the beginning. If I move the cot squared over, yeah, I'm going to get cosec squared minus cot squared is uno. So this here is uno. And we're left with cosec squared x plus cot squared x is a half plus root 2 cosec. Now from here we're going to have to convert everything into one trig function only. Are you going to do it in terms of cosec or cot? Well, because this is linear, we have to convert everything into cosec because there's nothing you can do with this. So that we're going to change into cosec by using this again. So cot is, move that over, cosec squared minus 1. So here we get cosec squared x plus cot squared, which is cosec squared minus 1 is a half plus root 2 cosec x. So we get 2 cosec squared minus 1 is a half plus root 2 cosec x. Get rid of fractions, double everything. 4 cosec squared minus 2 is 1 plus 2 root 2 cosec x. Yeah, so I doubled everything. Double, 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 double. Now, here, you could have done it over here. I'm going to let u equal cosec x. Make the substitution. It just makes life a little bit easier for us. It also saves us from writing cosec so much. So we get 4u squared. Then that you're going to move over minus 2 root 2 u. Then we have minus 2 minus 1, which is minus 3, is 0. Now obviously we're not going to try and factorize that. I'm just going to go straight to the quadratic formula. U is negative b plus or minus root b squared. Now obviously I'm not writing the negative because when you square it doesn't make a difference. B squared minus 4 AC all over 2a. So you have to write this down, but then obviously we're just going to go into the calculator and use polynomial solver. So we're going to get cosec x is two values. Okay. Going into my polynomial solver, menu A, poly 4 minus 2 root 2 and minus 3. So I get root 14 plus root 2 over quattro. Now I'm going to store this because of what I'm going to do after. And I obviously get the negative version. Minus root 14 plus root 2 over 4. Because what we're going to do now, we have to reciprocate because we can't solve with cosec. We're going to get sine x is, now I stored this as a, so in the calculator, I'm going to store this one as b. In the calculator, I'm literally just going to do 1 over a. So I'm going to go menu, back to my normal mode, 1 over a, which is root 14 minus root 2 all over 3. And I'm going to check that value. Is 0.7758, which is good. Okay, so this is allowed. Let's check this one. So we get sine x, and I'm going to change it to 1 over b. I get, so you guys can't see it, but if you do 1 over this in your calculator, you get a negative, then the whole fraction. What that means is the negative of, it's just the calculator does not put the bracket, it's the negative of that whole thing. Okay, so the calculator literally has written this without the bracket. Now, if we convert that, that says minus 1.71, which is not allowed. You can't inverse sine that, yeah? So we're going to say sine x cannot equal this since sine x is between minus 1 and 1, okay? So just going to go back to this. So I'm just going to type in 1 over a again, which was this. I'm going to do inverse sine answer now. I'm in degrees, I need to change that to radians. Inverse sine answer. Wait, what? Is it really? 0.888? Oh, yeah. Yeah. So I get x is 0.88800. It's just quite a strange number. I'm going to store that as a, so I'm overwriting that a. Now, how do you work out the secondary value for sine? You do pi minus. So in degrees, it's 180 minus. In radians, it's pi minus. So pi minus, the answer is 2.25. I'm going to store that as b just in case I need to use it. Okay, so that's my primary value. This is my secondary value. Now, both of these are in the range because between 0 and 2 pi. So once you have the two values in the range, what do? You add and minus 2 pi. But since both of these are already in the range, and the range is 2 pi, if you add 2 pi, you're going to come out of the range anyway, right? So x is approximately, I'm just going to do it to three significant figures, 0.888, or should we just do both of them to 3 decimal places? 2.254. And those are our two solutions. This would be a massive question in your exam, guys. 7, 8 marks potentially, all right? So guys, if you learned something today, I would appreciate if you hit the like button, subscribe for more maths content. If you are interested in my A-level maths courses, links are in the description for more details. And feel free to join the Lung Gang Reddit to submit your own questions. I'll see you in the next video. Nice.